So, thank you very much for inviting me to this event. My name is Anastasyia Popova, and I'm a sustainability lead of Staticus. I'm not sure how familiar you are with the company, but I will still take a couple of minutes to give you a bit of background, who we are, what we're doing. So Staticus is one of the largest facade contractors in the Northern Europe, and we're specialized in unitized curtain wall systems. You can see here the map that pictures our offices and also the places where we have our projects. And you see that the big market is Scandinavia for us. So this is Norway, Sweden. We're located in Vilnius, as I think you know. We also have many projects in the UK. I'm personally located in Switzerland. Staticus is quite a large company. We're about 500 employees, and 100 employees out of these 500 are dedicated to design and engineering activities. And we have the whole supply chain integrated in our company. So we start taking care of the project by designing a concept, developing the design to the later stages, creating mock-ups, tests, then everything goes into production. Our factory in Vilnius, we distribute then to the construction site the assembled units wherever it has to go. We also take care of the installation and warranty and after warranty services. So this is quite a complicated supply chain that also has very high requirements in terms of sustainability performance, because we need to think about it in each stage of our activities. And my talk today will be dedicated mostly to embodied carbon assessment of high performance facades. And I will tell you about our methodology. How do we do it? How do we assess the embodied carbon? Which guidelines do we use? Which methods, which tools? And I will also show you some examples from our past projects and then current projects to give you an idea how this methodology is implemented in real life. I'd like to start with some inspiration. This is one of our most sustainable, let's say, projects. It's called the Åkern Portal, and it is located in Norway. And here in this project, we managed to save 45% of embodied carbon emissions in the building envelope. So we managed to reduce embodied carbon to less than 130 kilograms CO2 per square meter of the facade in the product stage, thanks to the use of recycled aluminium profiles. So this kind of recycled aluminium profiles, they have very high content of post-consumer aluminium scrap, which you can see here is 80%. And this allows to reduce embodied carbon content in the profile by a very large number, ending up with 2.3 kilograms CO2 equivalent for A1, A3 stage. I will tell you later also more about these stages. What do they mean? But A1, A3 stage, this is basically the product stage, which we also focus on in our calculations. When I started to work for Staticus, that was 1.5 years ago, we set a goal to assess and to reduce environmental impact of Staticus facades, focusing on embodied carbon emissions. And we wanted to be able to measure our results, because back then there was no methodology in place. There was also no specific software that would allow us to take a project or just take one unit and measure the carbon performance of this unit. So we had to start from scratch. And in order to do that, we had to look at each stage of our value chain, starting from our suppliers. where do we get materials from, what kind of materials do we purchase, do we have environmental product declarations for these materials, are there any specific software tools in place at the site of our suppliers that can assist us with the calculations. So that was the first step that you can see here. Then in the second step, we had to look at our production site. Do we know what is our annual energy consumption, for example? Do we know our annual CO2 emissions? Can we assign them to a project? What is happening with the transportation? What is happening with waste in our factory? So that was a very big focus. It's still a very big focus today. Then the next step was to think about the logistics. What kind of trucks are we using to transport the units to the construction site? Do we use hybrid vehicles, for example, or diesel vehicles in order to reduce the environmental footprint? Then the next stage that we don't have that much influence on is the use of the building, which is 50, 60 years, depending on the building type. There we can only influence it by maintaining it, by offering our warranty services, but unfortunately, this is not our responsibility anymore, and the building owner is usually taking care of this stage. And at the final stage of the product or of the building, we have to think about the recycling or reuse. And this is also something that Staticus has direct influence on, because that totally depends on the way we assemble the units and on the way we choose the materials for the facade. So we also try to provide information to our clients about end of life of the units, how they can be disassembled, which materials can be reused or recycled, in order to minimize also environmental footprint in 50 or 60 years at the end of life stage. I mentioned that we dedicated a lot of time looking at our operation at the factory and also at logistics. And here in this slide, you can see the summary of the measures that we're taking in our operation in order to reach our sustainability targets. So 100% of Staticus facilities are supplied with green electricity. And this is already a big step that helps us to reduce our environmental footprint. Moreover, out of this 100%, 50% is supplied from remote solar power plant that is located in Lithuania. Also, 100% of our factory's outdoor area is equipped with LED lighting in order to reduce our energy demand, and also more than a half of indoor area, and we try to achieve 80% coverage next year. Moreover, we use packaging foil that is post-consumer recycled polyethylene, which can be recycled further. And this again reduces environmental footprint of not only facade itself, but also the auxiliary materials. We also apply digital drawings only, which allows us to save 1 million paper sheets by 2024. And one small fact about biodiversity is that 1,100 square meters of Staticus outdoor area is grassland. So these measures we have direct control of on our premises. But we also know that the majority of our environmental footprint arises from the products that we buy from our suppliers. So if we look at the total carbon footprint of our units, we know that more than 90% is so-called product stage, which you can see here on the slide. So product stage comprises raw material extraction, transport to manufacturing plant, and manufacturing fabrication that is happening on the site of our suppliers. So since Staticus is assembling the units in the factory, we do not produce the glazing ourselves. We do not produce aluminum profiles ourselves. We purchase it from our suppliers. And A1, A3 stage, this is something that is happening on the side of our suppliers. So when we purchase the material, it already comes with the carbon footprint or environmental footprint that we have no control of. So the only way how we can reduce it is by choosing the materials with smaller environmental footprint or pressuring our suppliers to make some measures at their premises in order to reduce the footprint. Then there is another cycle that we are responsible for, and I shared the information with you earlier, how we try to reduce our own energy demand and also the footprint arising from the transportation, but this is just a small percentage, around 5% of the total footprint. Then A4, A5 stage, this is something that is happening already at the construction site. So this is the transport to the construction site and the installation process itself, which is also not very crucial compared to A1, A3 stages. And then, as I mentioned earlier, there is the use stage for the building and end of life stage. And each one of them has a specific number that represents carbon footprint. So we know that 90% of the total number arises at A1, A3 product stage. That's why we concentrate on this. And we also know that the industry is issuing guidelines looking at this stage specifically, and is also issuing the benchmarks focusing on A1, A3 stages. I want to share with you a guideline by the organization in the UK. It's called the London Energy Transformation Initiative, and they did a very great job writing a guideline called Climate Emergency Design Guide, where they highlight the benchmarks for the future buildings in terms of carbon emissions. And you can see on this slide also what I was trying to tell you earlier, that looking at A1, A3, A4, A5 stages, we see that A1, A3 is a crucial one. Also, if you compare the yellow part of this pie to the pink part of the pie, we can divide it into operational carbon, so-called, and embodied carbon. So operational carbon, this is the emissions that arise during the use stage of the building. So you have to heat the building, you have to supply it with the electricity, the energy for air conditioning, and so on. And embodied carbon is something that comes from the materials. Since Staticus is not responsible directly for the use stage of the building, I will talk about embodied carbon mostly. An interesting thing is that we see the shift in the percentages in general in buildings and future buildings, because we manage industry-wide to decarbonize our electricity grid. We also manage to use as few energy as possible due to better insulation of the buildings and the materials that we're using. So the trend that we are seeing is that the focus will be more on the embodied carbon than on the operational carbon in the future. So you can see that the buildings today, they have about 66% of operational carbon compared to 28% of embodied carbon. And in the future, for ultra low energy buildings that are very well insulated, that are built according to the newest standards, the operational energy will only be about 31%, while embodied carbon will be 66% of the whole building footprint. So this means that these relations are changing, and this is the reason why we have to focus so much on the embodied carbon and on the materials that we are using in our buildings. And if we talk about facade specifically, this guide guideline also provides a number that helps us to relate a little bit what is the contribution of the facade to total embodied carbon. So based on several case studies, 16% is assessed to be as a contribution of the facade. And also here you can see on the slide some baseline numbers and best practice numbers for whole building emissions that are considered by this guideline as a benchmark that buildings should satisfy. So if today it's about 800 kilograms CO2 per square meter of internal area, in 2030 it should be reduced to less than 300 kilograms CO2 per square meter of internal area. So this means that we have to take 16% of that and try to comply with this number. Here you can see a detailed calculation for embodied carbon. Is a quite simplified one, just using an Excel where we tried to find out what are the components in the unit, all of them, starting from big metal pieces and then finishing with like little bolts and screws. And our goal was to understand whether it makes sense to calculate each single bolt in these assessments, or it's better to focus on the most important components. And also we just did this exercise to develop a gut feeling which component groups contribute to the embodied carbon the most. So the result was that 95% of embodied carbon in the facade units comes from such components as systemic profiles. So this can be aluminium or steel profile, from glazing, from other metal components like tin sheets, could be also steel sheets, aluminium sheets, and insulation also plays a smaller but significant role. And then other components, they contribute only to 5% of the final embodied carbon value, such as bolts, plastic boards, gaskets, silicones, and that's why we decided that in future calculations we should neglect them and just put 5% on top of the values that we are getting, just accounting for the main components, because it is very time consuming to calculate the quantities of all the components, because usually in the databases the CO2 factors are given per kilogram of material. So in order to calculate embodied carbon, it is necessary first to find out what is the weight of the component, and only then you can multiply and get the CO2 factor for this component. So for example, in this unit, you end up with the value of 360 CO2 per square meter of the facade. And then if you want to compare it with the guidelines that are given per square meter of internal area, you would need to recalculate this number using a form factor of the building. But our calculations are showing that the buildings that are built now with business as usual method, let's say, they do not satisfy the requirements of LETI, and usually 40% or 70% of further reduction is needed. So these targets are very ambitious that are set by this UK guidelines, and it is very questionable if they can be satisfied in 2030. Here is another example of simplified calculations that we provide our clients with. So since there is a big difference between the design stages of the project, in the tender stage, the suppliers are not known, so we cannot use environmental product declaration sheets with the suppliers, and we need to use generic databases. And then compared to the later stage of the project, there is another flow of calculation, because there we can use use supplier-specific information. So here on this slide, you can see the diagrams that were created based on generic databases for the materials that exist in each country of Europe, more or less. Here we used the German database, and there it's possible to take just generic numbers during the tender stage, so that we don't need to speak about suppliers. This calculation comprises also the most important categories that we know have the largest contribution to embodied carbon, as I showed in the previous slide. So you can see here that in the reference design, we provide the client with about 9 different categories of the material, of the components that are present in the facade unit, and the biggest contribution comes from aluminum profiles, since metals have the highest embodied carbon. In order to reduce that, we offer the client to replace aluminum profiles with recycled aluminum, which already leads to 46% of the reduction. So this is always a very good way to reduce the embodied carbon in the facade, is just to replace the aluminum with recycled aluminum, which then also leads to higher cost. But unfortunately for now, there is no alternative to that. There is also a big challenge in the glass industry, because nowadays the metal suppliers, they did manage to offer some alternative and to offer recycled material, but in the glass industry, it's more challenging from technical point of view. That's why the footprint of glass hasn't really reduced much in the previous years, and there is still some innovation needed, and maybe also legislation in order to support the suppliers and to allow them to achieve reductions. So a final word, our main findings during this 1.5 years that I was busy with sustainability topic around facade industry working for Staticus are the following. So first of all, we see that in the industry, there is Europe-wide acceleration in setting carbon emission limits and benchmarks. And that's why it is very right point in time to start thinking about your own performance, whether you're able to assess it, whether there are already some benchmarks existing in the industry, or maybe given to you by your partners that you have to satisfy. For us, for example, it's very important to stay attractive for the banks, and banks, they're already asking us for our carbon performance. So this is already a very important sign that the work that we're doing is totally worth it. There is another challenge, that the existing benchmarks for the emission reduction, they do not exist nowadays specifically for the facades, but they exist rather at building level. So what I was showing you earlier, that there is this baseline and best practice numbers for the whole building per internal area of the building. And then we need to recalculate it in order to relate it with the facade itself, having this 16% approximation of the contribution. So this is quite challenging, because the construction industry itself is very fragmented. And if you work on the contractor side, you do not have the opportunity to have the whole package of information for the whole building. And it's much easier if you work, for example, in consulting, and you have more information for the whole building operation as well. And then it's much easier to conduct carbon assessments. But for us, it is quite difficult, because our information is limited. And also our responsibility in the building lifetime is also limited. We're at the very, very beginning. So what we know for 2025 and 2030, what our goals should be is, first of all, to reduce our own footprint as much as possible. We would also need to replace our heating system, for example, since our electricity is already green. The next step is to reduce the footprint arising from our heating system. We are considering installing a heat pump at our premises. And we also know that since the heaviest impact comes from A1, A3 product stage, the materials life cycle, we have to work closely with our supply chain. So first of all, we need to roll out the criteria to our suppliers and that they need to satisfy. We need to ask them to provide us with more information regarding the environmental performance of the products that we're buying from them. And we also need to develop an action plan with them as for the reduction of the carbon footprint. And if they are not able to satisfy that, we would need to then search also for alternative suppliers that are greener. But there is a big risk also to in the supply chain in general, because as you know, there was material crisis last year, and this years in general are very turbulent. So there is a risk of just losing the supplier if you create too much pressure on the sustainability side. That's why we need to be very careful here and just search for the alternatives and keep all the options open. We also know that we need to pay a lot of attention on the whole life cycle thinking. So not only A1, A3 stages, but also end of life stage. And we have a circular economy project dedicated to disassembly of the facades so that we can provide our clients and building operator with a material passport that would include the description about the lifetime of each component, the point in time when it has to be replaced, how it can be recycled, how it can be reused. And this would also help us to close the material loop. So here is the majority of the information that I wanted to share with you. If you have any questions, please go ahead. You can also find me on LinkedIn if you will have any questions.